In this video, we will learn to code the Melody Maker application, where you click to add notes on a stave and see what melody comes out. We will build this application using HTML canvas, vanilla JavaScript, and we will even synthesize the sound using code.
And if you are new to sound in JavaScript, you can check out my video first. I cover JavaScript audio from complete basics to advanced audio analysis and visualizers in a single tutorial.
Thank you, Frank. Now let's start coding. We'll start with the main HTML page. I'll quickly define the head and body sections and link two external files like this. First, a JavaScript file that will contain the main functionality and a CSS file for some styles. The only thing in the body will be a canvas. This will be a canvas app. And to start the functionality, I'll call a JavaScript function called main onload. If we try to run it now, we will get an error because this main function is missing. So I'm switching to the JavaScript file to implement it now. I begin by referring to the canvas element, and I set it as a global variable because we will need to access it from different parts of the code. I also want to fit our canvas to the screen size, so I implement a function for this as well, where I just set the size of the canvas to that of the window. Now, when debugging, we see that scroll bars appear on the sides, and if I use the debugging tools, we notice a small margin on the top and on the left. This is the default behavior in some browsers, and to remove it, we need to do this using CSS. So I will make this change in the CSS file. It's the only thing we will do using CSS. Next, let's move on and draw the scene. I'll first get the Canvas 2D context, which contains all drawing methods we will need in this project. Then, in our application, we need to be able to add notes on a stave. Notes can exist on these lines, but also on the blank spaces between the lines. And I want to allow users to add notes above and below the stave as well. So what we need to define is a spacing between all possible vertical locations of the notes. I think 20 is a good value here, where each space is 5% of the canvas height. I will draw the stave next using black lines with 1 pixel thickness. I only need to draw 5 lines in the middle of the screen. So I will loop from -2 to +2, and I calculate the y relative to the middle of the screen. And based on the value of I and the spacing multiplied by 2, because I want to skip these in-between lines where notes can exist. At this Y location, I draw a line from the left side of the screen to the right side of the screen. Looking good. Next, let's make a function that can draw a note at a given location. For now, I'll use the center of the screen while I implement the function. The notes will have a black fill and stroke, and a line thickness of 1 pixel. I will draw them as circles at the given location with a fixed radius. To draw a full circle, the arc method needs 2 more arguments, for the start and end angle, which we want to be 0 and 2 pi radians, or 360 degrees. The radius should be the same size as the spacing. Good. The circle is now there, but I would like the application to look nice on different screen sizes, and now this is not adapting properly. So I'll add an event listener for the resize on the window and say that I want to call our fit-to-screen function here as well. Let's also refactor a bit and define the spacing here before we redraw the scene. I can now use the global variable to replace the value of the spacing everywhere it is needed. Great, now everything adapts to the size of the screen. Next, let's go back to the drawNote function and make it look nicer. Some notes have a line on the right side. I'll draw that now using the spacing value on the X here as well. And I'll say that the line should be 5 times the spacing in length. Some nodes also have a tail on the right, and I will draw that using Bezier curves. I want my curve to start at this location and have two control points, here and here. Nice, but if we want to stylize it a bit more, we can draw another curve as well, with slightly different control points. And fill the space in between. One more thing we can do is draw the circle as a slightly rotated oval. To do that, I first save the context state, then translate it to the location, rotate by a small amount, and scale it so that it is more stretched horizontally than vertically. I found these values by trial and error. Then, in the arc method, we can just use 0, 0 for the location because the translate method already moved us to where we need to be. Finally, we need to remember to restore the context to the last saved state. Otherwise, anything we draw after this will be offset in a weird way. Great, so now we can draw a good-looking note and everything resizes as we expected. Because we draw the note in code like this, we will see later that we can add parameters to this function and draw different-looking notes when needed. This, of course, could also be done using sprites. So next I'll show you how to do that as well when drawing the clef. I'll draw the clef using PowerPoint. For reference, I use the line tool to make a stave. Then I go to Arrange and distribute these vertically. Next, I'll make a rough sketch of the clef here for reference using the Freeform tool. This doesn't need to be perfect, just give a rough idea what we are aiming at. Then I draw a few control points here on the left at key locations of the shape. I then right-click and select Edit Points. This now lets us move the control points manually to get the shape that we need. A good thing to consider here is that the control points should be in line with the main one. Otherwise, your shape will start to have corners or sharp turns, and this clef is not sharp in any way. Now, this is very much like the curves we made using code previously, and this clef could definitely be drawn like that. But since there are more control points to work with, it's easier to use a software that can help. I use PowerPoint because I'm familiar with it, but these features are available in all vector drawing software. I'll now change its outline to black and increase the thickness slightly. But I would like the line thickness to vary along the curve. It looks nicer in that way. There is no easy way to do this in PowerPoint, but I came up with a trick that you can use. Hold the Ctrl key and drag the shape to copy it, and you can see that we can get some variation in thickness in this way. I want to align this part here so it looks like the drawing starts at a single point. Then I copy this shape multiple times to fill in the gap. Okay, this is good enough for a 4-minute drawing, don't you think? I'll add a circle here at the end to mask this not so nice looking part, but also to make it look better, I think. Then I group all these things in a single object and copy it by holding Ctrl key again. I can now make different styles by using different color glows. In this tutorial I will only use the black and white clef, but the final application has all of these variants used in some way. You can save these as transparent PNG images by right-clicking and pressing Save as Picture. Then, back in the code, I use a global variable for the clef image, which I initialize with the one I just drew. To add it on the canvas, I make a function called drawClef. I want this image to also scale nicely with the canvas, so I first compute its aspect ratio and then compute the height for the clef as, say, 50% of the canvas height. And I set the width by preserving the aspect ratio. To draw the image, I use the draw image method and say where it should be and at what size. I then call this in the draw scene function, but I move it a bit to the left from the node so that they don't overlap. Now, you can see that this is not what you might expect because the location refers to the top left corner of the image. We need to update the draw clef function to translate the image by half its width and height so that we work with the center point. Much better. Let me play with this size a bit. It's too small, I think. Better, but maybe a bit too large now. Good. One of the few things I remember from music class is that these points should touch those specific stave lines. Okay, now I will make it so that we can move the note using the mouse. I will need to add some more event listeners, and we'll refactor this a bit so that the screen resize event listener is also moved here. The new event listeners we will need are going to be for mouse move, mouse down, and mouse up. I will define an object for the mouse to keep track of its state, the location, and if the button is down or not, and then proceed to implement the callback functions for the event listeners. On mouse move, we simply update the mouse location with the information we get from the event. On mouse down, we modify the isDown attribute, and this is also where we will later add a note on the stave. On mouse up, we just mark that the mouse is not down anymore. Then, to animate things on the canvas, I will make a function that draws the scene and then uses requestAnimationFrame to call this function again and again as fast as possible. It will target 60 frames per second, but it will depend on the speed of your device. Now let's test and draw notes at the mouse location. Oops, we have an error. I used equals here instead of a column. Now it works. Somehow. It draws new notes every time I move the mouse, but it doesn't clear the canvas at each frame. So it looks like a trail of notes instead of what I need. I will now clear the canvas using the clearRect function starting at 0, 0 and using the full width and height. Now we can see that the note seemingly follows the mouse. But I want the X value of the note to be fixed somewhere on the right side of the screen. So I'll define a margin right to be 80% of the canvas width. And I'll also define a margin left that we need for the clef. These will be global variables. Then the clef is drawn at this left margin and in the middle of the screen vertically. And the note will be drawn so that the X is always margin right and only the Y value of the mouse. Let's see. The clef is in the right spot, but the note is still where the mouse is. I forgot to change here to use this location variable instead. Now we can see that the note location changes only vertically. Great. But I would like the note to snap to these locations that are acceptable. There are 21, spacing +1, of these acceptable locations. I can get the index of these locations like this, using the round function of the math library. Then I can scale this index based on the spacing to get the Y value. Now the note snaps as expected. I will define what these notes are using a simple array. We will be able to create 21 different notes, and these are their names. The ones that are over the stave are sometimes called by these other names. Each one of these notes is a sound that plays at a different frequency. I found these values by just searching online. And I will need these to generate the sound later. We are now ready to implement the moving notes. I will use an array to store every moving note and create a class for them as well. These moving notes will start at the location of the mouse. And we can calculate the index and the corresponding frequency from the frequency array. We add the draw method, which just calls the drawNote function using the given context and location. We need to update the location here as well, in the same way we did for the note that moves using the mouse, so that it snaps to the stave. To add a new note, we update the mouseDown callback function to add a new moving note to the array. And we update the drawScene function to draw all moving notes. We can test at this stage and see that when clicking the mouse, a new note appears on the screen. All new notes should start at the right margin though, so we need to change this here. All these notes need to move towards the clef, right? So I will need a function that updates all of their locations using a for loop. Each moving note will move towards the left with a speed that is again relative to the canvas size. In this way, the notes will reach the clef in the same time, no matter what your screen size is. A speed of 5% of the canvas width is good in practice, I think. Now I play the moving notes that have reached the left margin, where the clef is. I'll also remove this note from the moving notes array using the splice method. This shifts all following notes by 1, so I need to reduce I by 1 here. Otherwise I may skip a note in case 2 of them need to be played at once. For now, I will make this play method just print out the frequency value in the console, and let's test to see if this works. The note appears where it should, and moves towards the clef. When it reaches there, the frequency value appears in the console and the note disappears. Is this too much to take in all at once? Am I going too fast? Let me know in the comments what you think, and please like this video if you're learning something from it. Now, to generate the sound, I will use an audio context, which is part of the Web Audio API, which, similar to the Canvas API, is also native and we don't need any external libraries for it. I initialize the context here when we play the first note, because browsers need to have some sort of interaction before it can be used. And since we need the user to click to generate the first note, we know that interaction has happened at this stage. Then, to make the sound, I will use a simple oscillator, which I set to the corresponding frequency. I start this oscillator at the current time, and I also tell it to stop after some duration. I need to connect this oscillator to the destination so that we can actually hear something, and specify a duration of 1 second per note. Let's see what happens. We can hear that notes make a sound now when they reach the clef. But they don't sound really nice. I will modify the sounds to be more like a piano by increasing their gain from 0 to a larger value here quite quickly. And then going back down to 0 as the duration passes. Let me move this duration now here and test. There's no change yet. We need to connect this oscillator to the gain node first, and then link this gain to the destination. The diagram for it looks like this. If you are confused, you can check my VWD course. In this lecture, I teach how to make a piano and audio visualizer, and I explain how each of these methods work more carefully. Also, Frank covers many of these in the first part of this video, which is very beginner-friendly. He not only teaches oscillators, but also shows how to play sound files here instead. But yeah, let's see. Much better now. We can get even more melodious sounds by changing the wave type from a sine to a triangle. Great, we're almost done. I want to support more note types with different durations. So let's add the duration of the note here as a parameter and store it as an attribute. I will replace the value here to be that one instead. Then, on mouse down, we will create the note with the shortest duration first, so I'll pass here 0.5. Then, to show that the notes are different, I will pass this duration to the drawNote function too, and modify it slightly based on that value. Only the 0.5 note will have the tail on the right. The vertical line can also be missing for the longest duration of 4. The last two note types don't have a fill, so I will only apply it when the duration is smaller than or equal to 1. To create these other types of notes, we will press and hold the mouse button, and the duration will increase based on that. So we need to record here the time when the note was first created. Then I add an update method that measures the time difference, and the note type will be based on the hold duration. And I change the duration attribute based on this type. For the hold duration, I find that the value of 300 milliseconds is good. So the type of the note changes every 300 milliseconds now. I will now need to call this update method, and I will do it in the updateMovingNotes function. First, I need to check if the mouse is down, and if there are any moving notes to begin with. If these are true, I update the last moving note. Now, if I just click, I get a simple note as before. But if I click and hold, it iterates through all the note types until I release the mouse. Then we also hear a clear difference when the note reaches the clef. Okay, the last thing that I'll do is make this note that follows the mouse look like the one with the smallest duration, because it is the first in the sequence. That's it for today. Find the code to the full app in the description. It has a few more polished features, so let me know what you think. And if you have any questions, just write them in the comments. Let me know if you would like to see another video where I implement the rest of this functionality, or if this one was enough. Also, if you have ideas how to improve it, tell me those as well. Thanks for staying till the end. I hope it was worth your time.